This is an example of an ester hydrolysis that is catalyzed by base. The base is more than just a catalyst in this case, and it actually acts as a part of the product, as you'll see in the end. This is also known as alkaline hydrolysis because bases are also called alkaline solutions. And this is also known as saponification, which is a reaction that you saw in the lab. For this hydrolysis, we're going to start with the ester ethyl butanoate. So that means that the carbonyl part of the ester is going to have 4 carbons in it because it's the butanoate. The carbon chain attached to the singly bonded oxygen will be an ethyl group, so that means it has 2 carbons, 1, 2. So this is ethyl butanoate. In order to achieve this hydrolysis, we need to have water and we need to have a base. The base that we're going to use is sodium hydroxide. And to show that there is water present, we're going to say that it's aqueous sodium hydroxide. So that means it is sodium hydroxide dissolved in water. For this hydrolysis to happen, we need there to be heat as a product. Now, we know that in the hydrolysis of an ester, we're going to form an alcohol from the ethyl portion. So I'm going to write that alcohol as our second product. So this is ethanol. And we also know from the previous ester hydrolysis example that we've done in acid conditions, we know that we are going to form an alcohol and a carboxylic acid. So I'm going to quickly draw the carboxylic acid that would form up here because something's going to happen to that carboxylic acid. So the carboxylic acid that we're going to form is butanoic acid. However, butanoic acid is, after all, an acid. And because there is sodium hydroxide present in this reaction solution, it's going to react with the sodium hydroxide. So the carboxylic acid, the butanoic acid, will very quickly react with the sodium hydroxide and undergo a neutralization reaction. And the result of that neutralization reaction will be that the OH and the H get together. We will be left with a carboxylate ion that will pair up with the sodium cation to make a carboxylate salt. So our product will be sodium butanoate. So the moral of this story is that any time we have an ester hydrolysis or any time that we have a carboxylic acid, we have to consider the acid or base properties of the solution. And if the carboxylic acid is present with a base, it's going to undergo neutralization and we're going to get a carboxylate salt. So the product of the alkaline hydrolysis of ethyl butanoate will be the carboxylate salt, sodium butanoate, and ethanol.